All right. So our first lesson, I guess, for quadratic functions is going to be on factoring GCF. And today is 9/18. Yep. So we're in quadratic functions, and if you're like, wait a minute, didn't we do quadratics in Math 1? Yes, we did. So what we're going to do with Math 2 in quadratics is take everything we did in Math 1 and go a little bit further with it. We're going to dive deeper into different ways you can write quadratics or ways they're useful. Okay? We're also going to continue solving quadratic equations. That's actually chapter 4 because quadratics are a big part of Math 2. But the solving gets real wild. It's a lot of fun. So, but before we do any of that, we need to review some of the Math 1 stuff because quadratics tends to be the toughest part of Math 1, factoring the GCF included. So before we actually factor GCF, let's instead just practice dividing a polynomial. That's a polynomial. Hey, Kale, if you would like, you're welcome to move up to desk number 1. You what? Can you zoom in? Sure, give me just a second. I didn't pause it. Okay, so that's a polynomial. It's got 3 terms. 10x cubed is a term. 8x is a term. -6 is a term. Why are we starting with dividing polynomials instead of factoring the GCF? Because dividing polynomials is almost like I told you, a common factor. Okay? So let's put that in parentheses and divide it by 2. All we have to do is divide all those coefficients by 2. So 10 divided by 2, 8 divided by 2, -6 divided by 2. Ten divided by 2 is 5. Bring on over the x cubed. 8x divided by 2 is 4x. -6 divided by 2 is -3. So our final answer for dividing this is 5x cubed plus 4x minus 3. 36x squared minus 24x divided by 36. Or excuse me, plus 36. All divided by 4.
Wait, 4?
Just bear with me, okay? If some of you are like, wait, 4? 4 is not the GCF here.
Oh.
Well, we can still divide it. Here we're ignoring GCF for a second and just dividing it.
Oh.
Well, 36 divided by 4, negative 24 divided by 4, and 36 divided by 4. 36 divided by 4 gives us 9x squared. Negative 24 divided by 4 is negative 6x. 36 divided by 4 is another 9. The thing is here, I told you to divide by 4, but 4 is not the GCF, and the way I know that is because my answer can be divided further. The largest number that will evenly divide 36, negative 24, and 36 is 12. So let's redo number 2. But instead divide it by 12. (36x squared divided by 12 gives us 3x squared. Negative 24x divided by 12 is negative 2x. 36 divided by 12 is 3. This one, 3, negative 2, and 3 cannot be divided further. That's because 12 was the greatest common factor. If I tried to divide by anything bigger, I'm going to get some decimal answers or some fractions, which is like okay if you're dividing, but not okay for GCF. (16x to the 4th and 12x cubed). Let's first just divide it by something. How about 2x squared? Again, 2x squared is not the GCF. So 16 divided by 2 is 8. But here we're also dividing by an x squared. When we divide that, this exponent 2 gets subtracted off all the exponents. So 4 minus 2 gives us 2. Then divide the next coefficient by 2. 12 divided by 2 is 6. Subtract 2 off the exponent, 3 minus 2 is 1. We could call that 6x or 6x to the first power. But that could be divided further. What do you think is the largest coefficient, instead of 2, that I could divide 16 and 12 by and not get any fractions or decimals?
4.
4. So let's redo this one. Let's divide it by 4x squared instead of 2x squared. (16) divided by 4 is 4. X to the 4th divided by x squared, 4 minus 2 is 2. Then 12 divided by 4 is 3. X to the 3rd divided by x to the 2nd, 3 minus 2 is 1. Again, you could call that 3x or 3x to the first power. Hey, guess what? That still wasn't the GCF. Can I divide that any further?
Yes.
By what?
By x is cubed, I believe it's called.
Yeah. So I can divide this one further. Let's just take a little note here. The GCF is the largest term that will evenly divide every term of a polynomial. So we already saw that 2x squared was not the largest thing because we could actually divide it by 4x squared. But 4x squared is not the largest term that I'll divide by either because we've got those x's. Let's get 16x to the 4th plus 12x cubed. I'd like to expand that for a second. So 16 is really just a 4 times 4 in disguise. X to the 4th is x times x times x times x, all scrunched up together. Then that positive 12 could be rewritten as 4 times 3. And x cubed could be written as x times x times x. So GCF is what do they have in common? Well, they've got a 4 in common, and they've got 3 x's in common. So the GCF is 4 times x times x times x, which is just 4x cubed. The leftovers is 4x plus 3. So how you write your answer for factoring GCF, it's not like up here where I told you what to divide by. You have to tell what you divided by, what the GCF was first, by writing the GCF first. And then in parentheses, what was left over. That is the factored expression that's been factored for its GCF. Let's work through a couple more GCF examples. So the big trick here is I'm not telling you what to divide by. That's the big scary part here, is you have to figure out what you can divide by. (18x to the 4th minus 12x cubed). So a couple of thoughts that make this a little bit easier. We need a GCF of the coefficients 18 and negative 12. Okay? Well, if I'm looking for the largest factor that divides them, I'm going to be looking at the smallest number. Because, like, for example, 18, one of the factors of 18 is 18, but that's definitely not going to divide 12 because it's larger. So the numbers that divide 12 evenly are 1, 2, 3, 4, 6, and 12. Does 12 divide 18? No, not evenly. So it's no longer a candidate. Does 6 divide 18? Yes, it does. That's the GCF. Even though 3 and 2 and 1 also divide 18, they're not the largest number. 4 doesn't evenly divide 18. Then for the x's, just take the lowest degree variable. We've got x to the 4th and x to the 3rd. So between x to the 4th and x to the 3rd, x to the 3rd is the lowest degree variable there. So our GCF is 6x cubed. Anytime you're factoring GCF, write the GCF first. 6x cubed. Then in parentheses, carry out the division of 6x cubed. What's 18 divided by 6? Somebody, say it loud and proud. 3.
Isn't it supposed to be 3x though? And since you got the x3 squared divided by the x4.
I haven't got there yet.
Oh.
You're just a little bit ahead of me. That was my next question. For the exponents, 4 subtract 3 off of it gives me x, or x to the first power. Then divide negative 12 by 6. You get negative 2. Subtract for the exponent 3 minus 3. That becomes 0, which cancels out. Your final answer is 6x cubed times 3x minus 2. I want to do 2 more examples together, okay? (5x to the 6th minus 10x to the 4th plus 5x squared). Looking at just the coefficients, 5, negative 10, and 5. The smallest coefficient is 5. That's a prime number. Does 5 evenly divide 5, negative 10, and 5? Yeah. So 5 is the GCF of the coefficients. For the x's, I've got x to the 6th, x to the 4th, x squared. What is the lowest degree? The smallest exponent? 2.
X.
The GCF is 5x squared. Carry out all the divisions. 5 divided by 5 is 1. X to the 6th divided by x to the 2nd, 6 minus 2 is 4. You can just call this x to the 4th or 1x to the 4th. It does not matter. Just know in a multiple choice, the 1 would not be there. Okay. Negative 10 divided by 5 is negative 2. X to the 4th divided by x squared. 4 minus 2 is 2. Here's a really tricky part where lots of people mess up. 5 divided by 5 is 1. A second ago we said we didn't have to write it. However, here 2 minus 2 is 0. That also cancels out. So do I just close the parentheses and move on with my life? No. 5 divided by 5 is 1. X squared divided by x squared is 1. We have to put this plus 1 at the end. You can check your work by distributing, but if you didn't have that plus 1 at the end, you couldn't distribute 5x squared to it and end up with a 5x squared back to where we started. One more example that I want to go over together. Look at those 4 beautiful terms. 6x to the 8th minus 9x to the 6th plus x to the 5th minus 12x to the 4th. So for my coefficients, is there a GCF? You're thinking, yeah, 6, 9, and 12, heck yeah there is, divide them all by 3. No. Because there's actually 4 coefficients. I didn't say one. I've got 6, negative 9, and negative 12. What's the 4th coefficient?
It's a 1.
1. Is there a GCF among the coefficients? No. Y'all please get your heads up. But there's still a GCF amongst the variables. X to the 8th, to the 6th, to the 5th, to the 4th. The smallest exponent is 4. So that's my GCF. X to the 4th power. All I got to do from here is subtract 4 from all of the exponents. 8 minus 4, 6 minus 4, 5 minus 4, and 4 minus 4. The coefficients, we're not going to change them at all. We end up with 6x to the 4th minus 9x squared one x to the 5th divided by x to the 4th just gives us 1x or x. You can say 1x to the 1st power if you want. You just wouldn't see either of those ones on a multiple choice. Then minus 12. It's all good. At least it was a nice, soothing tone, you know? Could have been like something horrible and trashy and inappropriate. And they don't have to throw out this whole recording because it was saying something like, I can't even think of something inappropriate off the top of my head. That's just how vanilla I am. Although I kind of would have laughed if it just started going, I like big butts and I cannot. You know, like I would have left that on the recording. Okay, how are we feeling about GCF?
Good.
We feeling okay-ish? I'm going to give you 3 more. I'm not going to teach them. I'm just going to ask you to try them on your own. Try those 3, please. As you're wrapping up those 3, if you want to look up here and check your work. The first one, a GCF, would be 10x to the 6th. 10 is the largest number that divides 10 and negative 20. X to the 6th is the largest, or excuse me, the lowest degree there, so it's the largest that'll actually divide everything. The next one was 7x to the 4th. The last one was just 17. Can you hang on just a little bit longer? 68x cubed and negative 17x had an x to give, but 34 didn't. So all I could try to do was take out a GCF from the coefficients. Okay, I lied. I've got one more example. What do you do if there's only variables? That's kind of gross looking, right? I mean, like, yeah, but just take it piece by piece. For the x's, the largest variable that will evenly divide everything is just the smallest degree. X to the 8th versus x to the 7th. The GCF of those two is x to the 7th. So 8 minus 7 and 7 minus 7.
Why does 1z have a line through
What are you talking about?
it? Don't gaslight me.
Surely it just must have been a glare on the screen. I have no idea what you're talking about. With the y's, y to the 6th versus y to the 5th. Well, y to the 5th. So 6 minus 5 and 5 minus 5. For the z's, z cubed and z squared. Well, z squared. So 3 minus 2 and 2 minus 2. So let's actually subtract all that. X to the 8th minus 7 just gives me x. Y to the 6 minus 5 just gives me y. Z to the 3 minus 2 just gives me z. Ew, and then I've got 7 minus 7 and 5 minus 5 and 2 minus 2. What happens to all of that? It just divides or subtracts down to 0.
They all
They all die. Wow, okay. And what do I do there? Close the parentheses, move on with my life?
Should you just put a 1?
Just put a plus 1. That plus 1 comes from the fact that technically there were some coefficients here of 1 and 1. Because all of those variables went away, that 1 is the only thing that's left over. Questions, comments, concerns? Okay. Because I'm mean and evil.